Now we are going to look at some details of thalamus and hypothalamus. Both of them belong to diencephalon part of the brain. First, we will be talking about thalamus and then some hypothalamic nuclei, their functions, and maybe the lesions in some of them. Now, when we are talking about diencephalon, magnifying it, we will see that one of the diagram is that of thalamus and the other is hypothalamus. Actually, hypothalamus means below the thalamus. So, above that will be thalamus, below that is hypothalamus. But first, we are going to focus upon thalamus. Actually, the kind of questions come are about the nuclei of thalamus and what are the functions. That is something which we have to talk about. So, as you see, thalamus, we will draw a diagram, but before the diagram is drawn, you just have some idea. In the thalamus, there will be anterior group of the nuclei, which are basically part of the limbic system, the Papez circuit, if you remember. Do you remember the Gajini story? So, it is about the Papez circuit, and if you remember, we have discussed there was some hippocampus sending the information to fornix, to the hypothalamus and thalamus. Which nucleus of thalamus? Anterior nucleus of thalamus. That yellow color, you know, that yellow color. You can see here, I'll mark it. This yellow color is the anterior group. So that is part of limbic system, Papez circuit for emotions and memory. Emotions and memory. Limbic system. Now, what about the second one, which is medial group? Actually, medial group also is something to do with emotions, but it is about the awareness of emotions, that we are aware of emotions. That awareness is given by this nucleus, the green color, you see, medial. So, the green color is medial group. Yes, this one. And this is the one which is involved in some actually, you know, we have a frontal cortex and prefrontal cortex, which prefrontal cortex is for our emotions and social activity and our attitude, behavior, all that. It's all limbic system thing. And especially the awareness of emotions, prefrontal cortex. Then we have got this ventral group. And when you are talking about ventral group, which is here, this area, I'll use some other color. This area, this is something to do with you know, there will be actually ventro-postero-lateral nucleus, ventro-postero-medial nucleus. Now, when you're talking about ventro-postero-medial or ventro-postero-lateral, the VPM is for the head region, this is for the body region. We'll see this again as well, but what are they doing basically? So, this ventral group itself will have ventro-posterolateral and ventro-posteromedial. Actually, ventro-posterolateral is receiving some of the tracts, which you have discussed earlier also, coming from the body, like bringing touch from the body. What were they? That was the spinothalamic tract and dorsal column. So understand, spinothalamic tract and dorsal column, which will bring the touch sensation from upper limb and lower limb, will be coming to the VPL nucleus of thalamus before they reach the cerebrum. Actually, it is thalamus, it's a relay center. And when you say it is a relay center, before the information reaches the cerebrum, it must pass through thalamus. So, you mean to say you are touching upper limb, lower limb now? Yes. And spinothalamic tract, dorsal column activated. Right. And then it is coming to VPL nucleus of thalamus. Then it goes to cerebrum. Yeah. Which part of cerebrum? The parietal sensory cortex. So, it is about somatosensory output to the postcentral gyrus. What is postcentral gyrus? Postcentral parietal sensory cortex, area number 1, 2, 3. And then you can move on to the next thing. What is next thing? Actually, there is a violet color shown here now. And what about this violet color? This violet color you can see here is given some lateral group name. And it is basically again limbic system, something to do with emotions. So not a frequently asked question, just have some idea that there's a lateral group which is again, you know, related to some emotional functions of the limbic system, like that. And what about the metathalamus? Metathalamus we already have discussed earlier. Actually, posterior group, that blue color, lateral geniculate body and the medial geniculate body, lateral for the light and the medial for the music. So we have known that the lateral geniculate body light pathway, it is relay of the visual signal to the occipital lobe, lateral geniculate body. And what about the medial? Medial geniculate body we have seen it is to the temporal lobe. So this was about thalamus. Let us make a diagram ourselves to quickly recapitulate the information which we just gathered. Actually, this is thalamus we are looking at. There's an anterior nucleus. If you say this is the anterior nucleus, then what is it for? It is a part of the Papez circuit concerned with emotions and memory. So we are looking at the anterior nucleus, which is related to Papez circuit and concerned with some emotions and memory, and it is a part of limbic system. Actually, you have to understand that it is connected to the mammillary body of the hypothalamus. Now, if it is connected to mammillary body of the hypothalamus, what is mammillary body connected to? It is actually the fornix. And where is the fornix coming from? The hippocampus. So this is Papez circuit. Yes, it is. Hippocampus has short-term memory, will give it to the fornix to consolidate the memory, and then it will come to the hypothalamus, mammillary body, and from there it will come to the thalamus. Which nucleus? Thalamus anterior nucleus. That is the point. Okay, what about the other parts? We have discussed just now, there is the lateral geniculate body, medial geniculate body. What about the lateral and medial geniculate body? That is metathalamus. And what about the metathalamus? Metathalamus is related with the light pathway, visual pathway, and then the music pathway, the auditory pathway. And what was the VPL, VPM? Actually, there is a VPL nucleus and there is a VPM nucleus. Understand, VPL nucleus is receiving spinothalamic tract and the dorsal column because it is bringing some sensations from the body. And those sensations from the body could be touch sensation coming to VPL nucleus, where it will project further to cerebrum. It's a relay center, will project further to cerebrum. And which part of cerebrum? That is area number 1 to 3, post-central gyrus. So sensation of the body like touch sensation from the upper limb, lower limb, carried by spinothalamic tract, will come to the VPL nucleus of thalamus and further working like a relay center, projecting it to the cerebrum, area number 1 to 3, parietal sensory cortex, post-central gyrus. And what about the VPM? VPM brings the information from the face, touch the face, trigeminal pathways come here. So touching the face, yes. And trigeminal pathway activated, yes. Coming to VPM, yes. Where they go after that? Touch the face and the pathway activated is trigeminal pathway, and coming, the information reaches the VPM, and of course, from VPM also it will go the same place. Where? The area number 1, 2, 3. So area number 1, 2, 3, both of them, yes. Maybe it is VPL or VPM, both of them will go there. To the cerebrum, area number 1, 2, 3, it depends that what is the homunculus. If it is face, it is lower. If it is the body, it is more upper. It depends upon the homunculus. Face area, upper limb, lower limb area, body area, like that. So these are the 3 things which are important in the thalamus that you have to remember. Now, talking about hypothalamus. Hypothalamus has many nuclei, which some of them we have to remember, and let's do that. See, hypothalamus is below thalamus. Say if thalamus was here, below that is hypothalamus having many nuclei. And this is ventromedial satiety center. When you say ventromedial satiety center, just remember VMS, ventromedial is satiety center. If this area is activated, then you feel satisfied. Satiety means when I eat food, I keep eating food, and after some time this ventromedial satiety center is activated. Yes, then you say, okay, over. My requirement is over. This gives you satiety, satisfaction. And what if it is destroyed? Then you will never be satisfied. Obesity. There was an experiment done, and in that cat, this ventromedial satiety center was damaged, and you saw after some time, after a few days, cat became obesity. So destruction of this center can lead to obesity. Then where is the other center, the hunger center? It is lateral nucleus. It is the hunger center. So it is activated when you feel, when you are hungry. This is the one which will make you feel hungry, So hunger center, lateral nucleus of the hypothalamus. And what is the problem if it is destroyed? If it is destroyed, you will never feel hungry. Starvation. That is the point. And then you have to look at, see, our focus is according to the type of questions which are coming in the exam. That's what we do. So there is a question on anterior nucleus of hypothalamus. And what is it for? It is actually for dissipation of heat. For example, you are in Sahara Desert and it's hot. So you have to lose the heat. You are in Sahara Desert and you have to lose the heat. So how do you lose heat? You see, it is a parasympathetic system which is activated, and there will be some vasodilation in the periphery and lose the heat. So you mean to say parasympathetic system is activated, which will cause vasodilation in the periphery, and you lose the heat in Sahara Desert? Yes. What if I am in Antarctica? Shivering center, where is that? That is posterior nucleus. See, this is anterior nucleus and that is posterior. So posterior for conservation of heat in Antarctica. Yes. Shivering. See, the destruction can result in inability to thermoregulation. And it is actually stimulating sympathetic nervous system. What is sympathetic nervous system doing? Vasoconstriction. And why do you need vasoconstriction? To conserve the heat. Periphery, vasoconstriction. Skin will have vasoconstriction. Conserve the heat. You don't want to lose the heat in Antarctica. So, anteriorly you have the antagonistic nucleus to posterior. Just remember their functions. And now we want to talk about the paraventricular. Which ventricle? The third ventricle. You know, the hypothalamus is the lateral wall and the floor of third ventricle. So hypothalamus is the lateral wall and the floor of the third ventricle, and it is paraventricle nucleus now. Means on the side of the third ventricle. Yes, side of third ventricle. Side of the third ventricle, paraventricle. And supraoptic. What is supraoptic? Do you remember there was some optic chiasma at the floor of the third ventricle? So optic chiasma at the floor of third ventricle. I think there was some mammillary body also. Yeah, mammillary body also. Tuber cinereum also. Floor of the third ventricle, that is paraventricle nucleus. And there supraoptic means above the optic chiasma. What is it for? You already know. Actually, we want to regulate water balance, so antidiuretic hormone, and there is also release of oxytocin. What is oxytocin? It's a hormone. Gives you a nice feeling. Nice feeling means if oxytocin is released, you feel nice. What for? You may copulate and you may have babies. That for. Okay. What if I am baby now? You have to, release the baby. Oxytocin will cause uterine contraction and send the baby out. And when the baby is out, you have to feed the baby. So, stimulation of mammary gland secretion. All that is oxytocin. And what about the mammillary body you were talking about? Mammillary body we have seen is at the floor of the third ventricle. And you already know, Pape's circuit. So mammillary body is receiving information by a fornix, by the hippocampus. Hippocampus will send the information to fornix, will send to hypothalamus. Which part of hypothalamus? The mammillary body. And what if mammillary body compromised? What will happen? Pape's circuit compromised. See, it was projecting to anterior nucleus of thalamus, if you remember, and it is for emotions and memory. And then if it is damaged, like in Wernicke's encephalopathy, what happens? Antegrade amnesia, anterograde amnesia, confabulations are there. you will make stories which were not true, So mammillary bodies can be damaged in some hemorrhagic lesion, and there can be Wernicke's encephalopathy, there can be anterograde amnesia, loss of memory, and then there can be some confabulations, making some false stories just to fill in the gap of the memory, like that.